Assalamualaikum and hi, my name is AMYSHA MAIRA binti RUSLAN. I'm from group AS2446A. Today, I will present a research article about lichen as biomonitor of polycyclic aromatic hydrocarbon, which measuring the impact of features and traffic pattern. Now, let me start with a simple question. Can a simple lichen growing on a tree reveal the carcinogenic pollution produced by a road traffic? So, this question is the main idea behind this research. Polycyclic aromatic hydrocarbons, or we call it as PAH, are harmful pollutants that release from vehicle exhaust. Many PAH are known to be carcinogenic, which means they can increase the risk of cancer. Previous studies have shown that lichen can be used as a natural biomonitor to detect air pollutant. However, there is still limited understanding of how road characteristics such as road gradient, traffic light, and speed bump affect the amount of PAH that accumulate in lichen. So, this study aimed to investigate whether these road features influence PAH emission and whether lichen can effectively monitor these changes. Now, let's look at the methodology used in this study. There are a few steps included in this study, which is first, study area selection. Second, traffic and route feature assessment. Next, lichen sampling and sample preparation. Then, PAH extraction and analysis. Lastly, health risk and statistical analysis. The researchers carried out their study in Popayan, Colombia. They selected two different routes. The first road was the Pan America Highway, also called as PR. This road has high traffic light, and speed bumps. The second road was the National Highway, or NR, which has steeper road gradient but lower traffic. Next, they collected lichen samples from trees located near these roads. The samples were analyzed using gas chromatography mass spectrometry to identify and measure different PAH. They also use carcinogenic equivalence analysis, or KE, to estimate the overall carcinogenic risk of the PAH. Finally, they perform spearmint correlation analysis to determine the relationship between road characteristic and PAH concentration. However, this study also has some limitation. It only includes two road systems. The weather conditions such as wind and temperature were not fully considered, and the study area was relatively small. Here is the result from the article. The graph of A, B, and C shows the higher traffic lead to higher PAH produced. The researcher found that the urban road, or PR, had about 2.2 times higher PAH concentration than the national roads. This is mainly because PR had a much larger number of motorcycles and cars. More vehicles produce more exhaust emission, resulting in higher PAH accumulation in lichen. Next, graph A shows a total PAH in relation to road gradient in NR, and a graph B shows total PAH versus average gradient. The researcher found a very strong positive correlation with a spearmint correlation value of 0.98. This means that as a road becomes steeper, PAH concentration also increases. The reason is that vehicles need more fuel to climb uphill, which leads to greater pollutant emission. The third results involve traffic lights and speed bumps. The researchers observed that PAH concentration increased about 41% near this traffic control device. This happened because vehicles repeatedly slow down, stop, and accelerate, which increase fuel consumption and exhaust emission. Lastly, do you know that diesel vehicles can increase toxicity? The researcher shows that although PR had much higher total PAH, then our road show a higher proportion of the most toxic PAH. This is because NR had more heavy diesel vehicle, which produce more carcinogenic compound. So, a road with fewer vehicles does not always mean lower health risk. The author conclude that road geometry plays an important role in air pollution. Step roads, speed bumps, and traffic lights change the driving pattern by causing frequent braking and acceleration. These driving behaviors increase fuel consumption and produce more PAH. This study also advanced our understanding by showing that specific road features, not only traffic volume, influence pollutant level. From a practical perspective, lichen provide a simple and low-cost method for monitoring air pollution, especially in developing countries where expensive monitoring equipment may not be available. The author also suggested several future research directions. For example, future studies should include weather conditions such as wind and temperature, investigate more road types, study seasonal changes, and examine other traffic-related pollutants. Next, I will discuss the strength and limitation of this study. One major strength is the use of GCMS, which is a highly accurate technique for measuring PAH. Another strength is that the researcher collected data under real traffic conditions, making the findings more realistic than laboratory simulation. However, there are also several limitations, which is the study only covered a relatively short road distance of about 900 meters for each site. It also did not include a background control site, making it more difficult to compare pollution level with a clean environment. As a result, the finding cannot yet be generalized to all tropical regions. However, there are also some alternative explanations. For example, vegetation may naturally reduce air pollution. Wind direction and weather condition may affect pollutant movement. In addition, vehicle maintenance and fuel quality could also influence PAH emission. To conclude, this study demonstrates that lichen are reliable and cost-effective biomonitor for detecting traffic-related PAH. This study also shows that road characteristics such as road gradient, traffic light, and speed bumps significantly affect pollutant accumulation. From a biotechnology perspective, this research supports the use of living organisms as environmental monitoring tools. It also provides a practical solution for pollution monitoring in regions with limited resources. Finally, I would like to leave everyone with this question. Should road infrastructure projects be evaluated not only for traffic efficiency but also for their long-term impact on air quality and public health? In my opinion, the answer is yes. While efficient transportation is important, protecting human health and the environment should also be a priority. This study shows that road features such as step gradients, speed bumps, and traffic light can increase harmful pollutants. Therefore, future road planning should consider both traffic performance and environmental sustainability. By doing so, we can create roads that are not only efficient but also safer and healthier for the community. Thank you for your attention.